Hi, hello. So, how are you? Yeah. So, I think you are doing well today. Okay. So, yes, we are going to talk about Newton's first law of motion, right? So, this is also called the law of inertia. Uh, and before going into this topic, first we need to understand two terms. These two terms are nothing but first one is motion and then inertia. Okay. So, what is a motion? So, motion means change in position with the time is nothing but a motion. Like if an object is moving or changing its position or changing its place with time, that is called as a motion, right? So, let's take a real time example. We all love cricket, right? So, in that, if a bowler, if he want to do bowling, first he will run, right? So that running is nothing but a motion, and then he throws a ball, so that ball also move forward, right? That also a motion. And then the batsman also hit the ball, so after hitting the ball, that will move again, that is also a motion. So the batman runs, that is also a motion. Everything that is changing the position with the time is nothing but a motion, right? So we understood what is a motion, right? So let's move to the inertia. Okay. So what is an inertia? Okay. Yeah. Let's So before going into that, here I have provided a simple example. So object at rest, so that object velocity will be zero because it is in rest position on the table, right? So it is not in any motion. The state of the object is rest, right? So here object is in motion, constant speed and direction. So here the direction not changing, it is moving forward only. And yeah, it have a constant speed, right? So it is in motion, we can say it is in motion. If there is an acceleration and the object is moving, that also motion. Now let's move to inertia. So what is inertia? So before understanding that inertia, first we will understand a uh, simple fundamental logic. Okay. So if I have a low mass ball, if I have a ball that have low mass, low weight, okay, low weight. Let's suppose we take 1 kg of ball. Okay. If I push that ball, that will move move a long distance, right? Because the mass is less. So the change in the position will be huge. Okay. Let's move on to the next example. If we have a high mass of ball, okay, that is around a 10 kg of ball. Okay. So if I applied a same force or a same push, okay, if we are applying same force on both balls, this ball move a huge distance. But here in this case, this will this having a large amount of weight, right? So it's only move a least distance than this ball, because it having a high mass. That's why it only change a small distance, right? Let's for example, it moved around 10 meters, 10 meters. Then this will move only a few meters. Let's suppose it will only move a 1 meter or 2 meters, because it is containing high mass. That's why it moves only least distance. Okay. So what is inertia? Inertia is nothing but the resistance. Inertia is nothing but the resistance of an object to change in its state of motion. That means it always tries to oppose the changes in its state. That is nothing but a inertia. Okay. Inertia. Okay, understood. Okay. Yeah. Let's move on to the Newton's first law of motion. Okay. So a simple definition of Newton's first law of motion is This law states that if an object is in motion, it always tries to be in motion. If an object is in its rest position, that always tries to be in rest position unless and until any external force applied on that object. Okay. For example, if I have a box in its rest position, okay, somebody pulling from this side and some another person pulling from this side, so both are pulling this box in opposite direction and applying same force. So what happens, the box remains at that position only. It does not move in any direction because they both are applying same force, and also they are pulling in opposite direction. That's why it will be in rest position only. The entire force will be cancelled out, and the result force will be zero. The net force will be zero. Okay, understood? Just we need to understand, if I applied unbalanced forces, that will the box will move in a greater force direction. Okay, that's it. Yeah. So we have a Newton's first law of motion formula, like the sum of the forces, that is nothing but a net force. If it is zero, the object will remains at a same position or a constant position. If the resultant or a net force is not equal to zero, the object will move in the direction of a result. Okay, direction of a resultant force. Okay, so here the force applied on this object is less than in this direction, right? Here the force is 2 newtons and here it is 6 newton. The object, obviously the object will move in this direction, right? Some of the forces will be here 6 plus minus 2 newtons. Why? Because we will give negative value for opposite direction. If I say if it is a positive direction, then we need to give this as a negative direction, because both are opposite in direction, right? Opposite in direction. That's why we will give opposite sign for opposite direction. That's it. When we sum up all the forces acting on that body, that will give a resultant force, and also give a direction. When we introduce vectors, that will give a direction also. Okay, right. We already understood Newton's first law of motion formula, right? So let's begin the calculation. Okay, so yeah, here I took a simple example. I have it 2 kgs of box with equal pushes. That means I am applying same force in opposite direction. Like here in this direction I am applying 10 newtons, and in this direction I am applying 10 newtons, right? And the weight of this box is 2 kgs. Then the net resultant force will be zero, because right, they are cancelling out each other, because they have same force in opposite direction. That's why we are giving. So let's suppose it is a positive direction, then we should give it has a negative direction. That's it though. So the net resultant force will be zero. There will be no change in its motion or speed. If it having a speed, or it is moving forward with a velocity of 80 kilometer per hour. Let's suppose it is moving in this direction 80 kilometers per hour, and I applied a force 10 newtons in this direction, and another person applied a force in this direction 10 newtons. So the net resultant force will be zero, and the object motion doesn't change, and it's always in its it attain a same velocity. It does not change its velocity because there is no force acting on it. Yeah, there is a force, but they are cancelling each other. That's it. Okay, so the net force will be 10 newtons minus 10 newtons, that is 0 newtons. And acceleration, if we calculate an acceleration, we know that acceleration, we can say force is equal to mass into acceleration, and acceleration is equal to sum of the forces by mass. So sum of the forces will be 0 and the mass is 2. So 0 by something will be always 0. Okay, we understood what is the Newton's first law of motion, and that is also called as a law of inertia, right? So what is the Newton's first law of motion? What it states? It states that if an object is in motion, that always tries to be in motion. If an object is in a rest position, that always tries to be in rest position unless and until any external forces acts on it. Okay, if any external force acts on it, that can be change its direction or motion, right? That okay, that's it.